Hello learners, welcome to Atya Studies. Now we know exactly what is array, right? And we saw few programs on 1D and 2D arrays. Okay, here I will give small information on array list. After arrays, we need to study array list. So I will give brief information about array list over here. Okay, why array list? Why not arrays? Both have their pros and cons. When you know the size of array, better go for array. Okay, so array might not be a good idea where you don't know how much data you have to store in memory. Okay, so here we come with array list. Why array list? It is a dynamic version of array. Okay, what is mean by dynamic here? So I simply mean that it can grow or shrink based on the requirement. Okay, so now we have another alternative to dynamic required. We have linked list. Okay, I'll explain linked list clearly here. So here you can see two diagrams, right? So one from array list, right? Here if you see this diagram is of arrays. So mean I want to store data and I want to space deep on adding data, and do not worry about specifying size before, which means for that we need to use linked list, because if you have, let's suppose, if you know the data, okay, if you know the size of the array, how I'll create an array here? Int array, I know the size of array. Okay, here int rrr is equal to new int, it is a size of array of 5 elements. Okay, this is the array creation, right? Here we can see we can store only 5 elements because I have given the fixed length of array. But when you see, when you go for array list, no need to specify any array length. Okay, so let me minimize this. Here, so you don't know the array size, right? Array size of 5 elements. You have drawn the figure box over here. I want to store 5 elements. 1 2 3 4 5 elements were fixed in this array. This is our array worked before. But when you see array list, it will be grow. If you give any here, for suppose I have stored 10 here, 20 here, 30 here, 40 here, 50 here. If I want to store 60, then in array list it will automatically grow the array size and it accept the next element. Okay, that is what array list and linked list are. But what is the difference between them and why we use most linked list rather than array? Okay, so in array list you can store the elements in a continuous way. For suppose the array elements all store in a continuous way. But if you see the linked list, the elements were stored in random place in the memory. Okay, you must be see the data in continuous way rather than it will create nodes, okay, in each and every elements. If you store 10, it will store 10 in a memory. Here if you see, if you want to store 10, then it will store 10 over here. If you if you want to store 20, then it will store 20. But it is not a continuous flow. Okay, it will store at random place in a memory. If you want to store 30, it will store 30. If you want to store 40, it will store 40 and 50 and so on. But what is the connection between all these elements? Here we have a connection because each and every element is connected to the later memory. But here there is no connection, right? So how this connection will happen? The node may mostly have two. This is called data. Basically this is a node has two elements, I can say, that is data and this is next. Next is nothing but which is also node. Why I am saying next? Because it is like a address or reference to next node. Okay, so let's suppose understand I am giving here the address of 10 at the rate 100. It is address of this node. Let's take address of another 20. Let's take 20. Here this address is 150. If you take 30, the address for 30 is 200. Address of 40 is 250. And the address of 50 is, for suppose, 300. These are the addresses. So these are the nodes. Nodes have two elements. One is data, and the second box will store here address of the next element. You want a continuous to this element, right, to this node. So which element you want to store after 10? If you want to store after 10 20, then you need to give the address of 20 over here. Okay, I am giving 150, which is the address of 20. If you want to store here in 20, if you want to store 50 over here, I need to give address of 50. Okay, here in 50, if you want to store the address of 30, you need to give address of 30. If you want to store the element 30, then you need to give address of 30. Here in 30, if you want to give the address of 40, if you want to store element 40, you need to give address of 40 over here. And the last node, which is last node, so 10 is connected to C, 10 is connected to 20, okay, and 20 means 300, 20 is connected to 50, okay, here it is storing 200, which is the reference of 30 element. So here 50 is connected to 30, later 30 is connected to 40, and 40 is not connected to anything because the elements are completed here. So basically the last element contains null, which is empty. What you understand from the linked list is, linked list contains the elements in a splattered way, not in a contiguous way. Here if you see the elements, they were stored randomly in a memory, but they were interlinked to each other by storing the address of the next element. That's it. There is nothing in the linked list. Linked list are not stored in the continuous way. They will store them in the memory at random places. But what is the use of it? If you see, why not array list? Why array list? Here, if you see there, it don't take a lot of space before storing the elements. Okay, it will take a few space. If you want to store 30, then it will allocate to that memory which is requirement. It will work on based on requirement. Okay, so this is the way they will share the elements in the memory. They can't be continuous way, they are scattered way. Okay, so what is the benefits exactly this giving is? Now you don't resolve all space together, right? So you can create or look for space based on the requirement only. But how can we believe that these elements belong to one linked list based on the addresses? Okay, so basically it is a head, it is a node. A node has two elements. So these elements are interlinked based on the address. For suppose if I want to store 60 over here, see here I have a requirement 60. Node have here 60 as data. Okay, here it is storing. I want to store 60 later to 30. So I want to store the address of 30 over here. Then 60 has one address, right? So 60 address is, let's suppose, 600. So I want to connect this 30 after 60 after 30, right? So what I'll do, I'll erase this 200 here. Okay. Sorry, not 200. I need to erase 250. Okay. 30 store what? 600, right? So here what I will do, address of 60 will store, and it is pointing to 250, right? It never point to 250 now. It will point to where? It will point to 60. Okay, it will point to 60. So 60 point to 60.2, not 200 here. 60 will point to 250. Mainly what I mean to say here is it will purely work on addresses, the next node. So here if you see, the 60 is connected to 250. It won't disturb the elements, it will only work based on these references. Now if you see the elements over here, the contiguous, what are the elements in the linked list stored are, see here, first 10. Okay, 10 will store address of 150. Where is 150? Here, right? 150 element is 20. It will store 20. 20 address to 300. So what is 350 here? Okay, 50 stores 200. 200 is address of 30. Okay, 30. 30 stores 600. 600 is address of 60. 60 stores address of 250. Okay, which means 40. Yeah, 40 don't store anything. Here we have null. Yeah, that's it. This is the linked list, how the linked list will work. So this is the basic idea of linked list, and this is how we conclude. The elements will be stored in the memory. So one entry or one element identity linked list is nothing but one node to the node, which will be term, so which can be used in linked list a lot now. Okay, node will be used a lot in the linked list now. Okay, node, head, data, next, these are the elements will be used more in linked list. Let's understand the programs in next video. Thank you for watching the video till now.